All right, here we are with our last lesson of the school year for pre-flight math. We're looking at Concept 8, writing linear equations. So in this concept, you're going to learn to recognize functions and write linear equations. We have this setup here. Janet bought a flowering crabapple tree for her front lawn. The tree was 24 inches tall when she bought it, and it was she was told it would grow 6 inches in height every week. How can Janet figure out the height of the tree at the end of 6 weeks? So we'll eventually be attacking this problem here in a little bit, but first let's define some things. Really, everything that's defined in these definitions is review. We've been talking a lot about slope-intercept form of linear equations at this point. Y equals mx plus b, where m is the slope and b is the y-intercept. I am going to write out for you, just as a reminder, m being the slope can be calculated by doing y2 minus y1 divided by x2 minus x1. So I'll be using this formula quite a bit in today's lesson. And then remembering that b is the y-intercept, or where it crosses the y-axis, right? We'll also be taking a look at writing horizontal equations and vertical equations as well. So let's get started. Linear equations can be written in many forms, right? We've seen standard form and slope-intercept form. This here is just reminding you that m is the slope and b is the y-intercept, and that every equation has coordinates x and y. So we want to write the equation in a line that has a slope of 1/2 and passes through the point 0, -4. So the very first problem they give us, they say we have a slope equal to 1/2, and it passes through this point 0, -4. Well, if it's passing through the point 0, -4, notice how my x-coordinate is 0 here, but my y-coordinate is -4. Well, remember, when you're given a point where the x-coordinate is 0, this is really referring to your y-intercept. This is where the graph crosses the y-axis. We cross the y-axis at a value of -4. So all we really need to do is plug in the 1/2 for our value of m and plugging in -4 for our value of b. So we'll get the equation y equals 1/2 x minus 4. If you said 1/2 x plus a -4, know that that means the same thing, and that's totally okay. Let's look at another example. So here I give you the slope. So I'm going to adjust this. So here the textbook is telling us the slope is 3, and this time it passes through the point 9, 6. Well, they don't give us the y-intercept this time. This point 9, 6 is not telling us where it crosses the y-axis. So the only information we really have right now is m. So what we have currently is y equals 3x plus b. That's all we know. We don't know what the y-intercept is. But we are given this point that's a part of this equation that says, well, when x is 9, you should get a y value of 6 back out. Well, we can substitute those in. So I can say, well, when I plug 9 in for x, I should get 6 as my value back out. So carrying down the 3 and then carrying down the b. Because 3 is still our slope, and we don't know what b is. But notice how when we plug in x and y into the start of our equation of y equals 3x plus b, we're just left with one variable b that we can solve for. So we go through and we do 3 times 9, which is 27. Then we subtract 27. It was positive, so to bring it over to the other side with the goal of solving for b, we need to subtract it over. And 6 minus 27 is -21. So we get our value of b is -21. So now we can get an overall equation of y equals 3x minus 21. So we use that point to solve for b, and then we use the slope that they gave us to kind of start that off for us. Let's look at another method of how we could write these equations in slope-intercept form. So in this one, they give us 2 points. So they give us 2 points. They give us the point, let's see here, -2, 6. And 4, -6. Well, we're not given slope and we're not given the y-intercept, but we can find slope and we can eventually find the y-intercept too. Remember, to find slope, we need to label our points as x1 and y1 and x2 and y2, basically saying which point is the first and which point is the second. Because now I can use my equation for slope of y2 minus y1 over x2 minus x1. So I can take -6 minus 6 divided by 4 minus -2. Now when going through this, we need to remember that these double negatives in the denominator is going to make that really a plus. In the numerator, though, I have -6 minus 6. That's -12. In my denominator, I have 4 minus -2, but that's really like a plus there. So that's going to leave me with 4 plus 2, which is 6. -12 divided by 6 is -2. So in the end, I find m, my slope, to be -2. So that starts off my equation. I have -2x plus b. I know my slope m, so I can plug that in, but I don't know what b is. From this point, we need to figure out what our y-intercept is. Now, we can choose either of the 2 points. We were given 2 points. It does not matter which one we use next to solve for b. I'm going to use the first one, -2, 6, but it really does not make a difference. You could have used 4, -6, and you're going to get the same value for b as I do. So what I'm going to do now is I'm going to use -2, 6 to find b. Well, -2 is x and 6 is y, so I'm going to plug those in. And again, the goal is to solve for b. I want to figure out where this graph crosses the y-axis. -2 times -2 here, that gives me a +4. Subtracting the +4 over to cancel it out will give me 2 is equal to b. So now I know my linear equation is y equals -2x plus 2. I first had found my slope using the slope equation up here. Then I found b by picking one of those original points and plugging it in for x and y. And putting it all together, I get this equation.